Okay, so hello everyone. So I'm Pierre Maillot, former postdoc in the Wimix team and now research engineer in P16. And I'm going to talk to you about Corese that I've been working on since more than a year. So first, since Fabien Gandon already talked about Corese, there is going to be some overlap between our presentations. But I'm not going to re-explain to you what knowledge graphs are, but I am still going to have to talk a bit about some basic facts about knowledge graph. So I'm not going to re-explain what are triples. I'm not going to re-explain the details of knowledge graph. So we are describing things according to their relations with other things. But from an higher angle, from higher point of view, so knowledge graph became practical idea and became to be implemented in the 1970s. So there are several approaches that are still implemented today. So among them, property graphs, the knowledge graphs that have become the semantic web, and approaches that will mix both of those. I forgot the word. Both of those approaches. So the main differences between them is what is an edge, what is a node, what are you representing, how do you query the knowledge that is stored in the knowledge graph, and how you can serialize it, some details about implementations and formalizations. And the term semantic web was coined in 2001 in an article by Tim Berners-Lee. So in practice, the semantic web, which is the only kind of knowledge graph that is going to interest us for the presentation, was formalized by the series of standards that were created by the W3C. So starting in 2019, and with RDF for the data, then RDFS all to the schemas and the query language, and then the new version of the standards for schema and queries, and then Shackle to validate data, and the last one that Fabien talked about, the canonicalization of RDF. So, in terms of technology, so we have RDF, RDFS, and all to represent our triples. So with RDF for the triple and RDFS and all for schema. So we can define things, and we can define classes of things. We can define all the logic between the relations, the logic between the classes. We can query a knowledge graph with Sparkle queries. We are going to be able to validate our data in Shackle, with the interesting fact that we can define what we validate in Shackle in RDF, so we can validate RDF with RDF. Everything is made using only existing protocols, so we are not reinventing a new protocol. We're adding everything on the pile on the web technology, so everything is made to be used in with HTTP calls and with an API, a simple API. And we've seen that the semantic web knowledge graph has started to be used outside of just knowledge graph, but also used in GraphRag, used in the context of IoT for data lakes and etc. So Fabien already gave a lot of examples of those users in his presentation. And so the advantages of this semantic web graphs are the fact that we can describe almost anything reasonably. We can also integrate any semantic graph in another semantic web, in another knowledge graph. So it's almost as simple as a concatenation of two files if you want to add a graph given to you by someone else to use, almost at some trivial transformation approximately. And it's all based on standards, so there won't be any companies that will decide that the next API required a paid extension to be able to be used. So everything is managed by the W3C, so an international non-profit consortium. You have the possibility to add reasoning to your dataset. So with one triple and the right schema, you can automatically add several information to your dataset. So if you have a client that is declared as being an habitant of France, you can automatically infer that is going to be subject of the laws in France. You can infer that is going to have to respect some norms in the products you send to him, etc., etc. So you can write less to get more in your database. And since we can describe almost everything in RDF, you can also describe RDF in RDF. So you can add metadata to annotate the provenance of your information, and you can describe the provenance of your graph itself in RDF. So just to put a point of reference, because I've sometime had this question, so why use knowledge graph when we have good old SQL databases instead? So both are using a joint-based data management system with a query language. So in both cases, you're going to send a query and you're going to get a table as an answer. And in both cases, we also have a validation process with a constraint with shackle constraint for the semantic web. The difference with SQL databases is the fact that it's not very fair to compare them, because in the 80s, SQL was recognized as the main language to do databases in the world, while in 2008, Sparkle was created as a standard. So it's not really the same age of technology, not really the same maturation yet. Next, you can have a very flexible schema. You can declare any kind of classes, any kind of properties, and you can make them cohabit in the same knowledge graph. And contrary to SQL, you can modify on the fly your schema with a simple Sparkle queries without having to put down your database and restart it once again. And of course, it has been proved that it's really useful when you have different sources of data that you have to merge in the same knowledge graph, or if you have to integrate data from remote sources, or from different providers. So, in practical terms, and in the environment that Corese has been created, so we have different open source solutions with Apache-Gina, RDF4G by the Eclipse Foundation, and OpenLink Virtuoso, and we also have paid versions with, again, OpenLink Virtuoso, which has a free and a paid version, and the Autotest GraphRB, which is a paid implementation, paid fork of the Eclipse RDF4G implementation. And so I'm going to refer to you to the YouTube video of the presentation of Fabien Gandon about the uses. So, but there are different uses of those RDF knowledge graphs. So IBM and Siemens notably use them to agglomerate a lot of data from different sources in the same knowledge graph. Google, Amazon, Alibaba, and Walmart have communicated about the fact that they were using knowledge graph for their recommendation or for their search engines. And recently, Microsoft has published a paper describing how to use knowledge graph in a GraphRag solution. And NASA also have communicated on the fact that they were using knowledge graph for a query and for a question answering solution in the internal knowledge base. So all that to say, to give you a context, for you to understand where we are in Corese, because otherwise it will be a bit dry. And Corese, first, Corese is a semantic web factory that was started by Olivier Corby in '99. So the main characteristic of Corese and the really driving factors that we are keeping, that were the main characteristic of Corese and we are trying to keep in our development, the fact that we support all the standards given by the W3C, and we also try to support the exploration of new solutions around the semantic web. And we also, in the support of standard, we also support standards that are very rarely or not at all supported by other solutions. And we also offer all the tools that are necessary for the community for the spread of the usage of knowledge graphs. So I didn't give you the historical data of the semantic web for nothing. So when we say that Corese supports the standard, it means two things. That first, using the different Corese solution, you can use every standard in the semantic web. But also, if you don't know, to create a standard in W3C, you need to have, at the creation of standard, several implementation of the ongoing work on the standard that is trying to become recommended. And in most of the standards, Corese has been among the first implementation. So you see here with the marks that every time Corese is in the list in the report of the implementation of the standard. And we are going to try to follow this trend. But also, so Corese was since 99 research project, so there are also additions to Corese that are not standard but are useful. So Olivier Corby created a language that is an addition to Sparkle that is called ElderScript, which allows you to add programming to Sparkle Corese, which allows you notably to manipulate the data formats that are not handled by Sparkle Corese. So you can manipulate JSON inside of Sparkle Corese. You can load files inside your knowledge base using Sparkle Corese at the moment of the Sparkle Corese. You can do other API queries that are not Sparkle in the middle of the query. You can also manipulate more easily numbers, which are traditionally a big problem for most Sparkle engines. Corese also implement custom reasoning engines. That means that the RDFS and all reasoning and any reasoning you would want to add, you can add them simply using rules. And rules based on Sparkle queries. So if you know how to do Sparkle query, you can do reasoning with Corese. It just have to have a premise and a conclusion with two Sparkle queries. And also a feature that is not always available in all Sparkle engines, the fact that Corese offers federated queries, the fact that you can send a query to a remote endpoint, so different remote endpoints, you can send a query that will query your local database and remote database afterward. So when we say Corese, it's so first of all, it's everything in Java. It's everything in memory. There is no permanence of the database, and it's in 5 applications. So the core of the library of Corese is Corese core, so it's the library part of Corese, and it's the main things that we're concentrating on in a collaboration with Probable with P16. Then we have the Corese server, which is a Sparkle server, and Corese GUI, which is a heavy client standalone with a GUI that Fabien showed you as a screenshot this morning. We have also a wrapper, a Python wrapper to allow people that are more used to Python to use also knowledge graphs. And for persistent, we offer connectors to other solutions, so RDF4J and Gina, and that will allow you to store your database on disk. In research, so Corese is still used inside the Wimix team with the extension of Shackle that was published last year by Rémi Fella. We have 2 ongoing PhD theses. So Nicolas Robert is doing a thesis about injecting knowledge graph embeddings into models. And Céline Riwal is going to defend his thesis in December about learning RDF, about learning, about extracting facts using RDF patterns from bases. And there is an ongoing work on user interface with Aline Mona, who is also collaborating with us to redo the Corese GUI application. And in terms of industry, we've collaborated with probable to create a connector to Elasticsearch servers to be able to detect and update the Elasticsearch servers each time there is a modification to a knowledge graph, and to facilitate the text search on elements that will be in the knowledge graph. So, all this to tell you where we are in the collaboration with Probable to redo Corese to industry standards. So this is the general timeline that we've established. First, we've worked on a rework of the API, so on code that dated back to 99, where to refactor and to redo the API from scratch. We did an homage to RDF4J and took a lot of from them because they are the best Java API on the market for now. We also added a lot of tools to be able to work on Corese and to maintain the quality of our code. So we have a way to evaluate the support of the W3C automatically for each new version. We have a way to compare versions between themselves and to compare them on industry benchmark automatically at each new version. And then we've started to work on the basic I/O, so in the basic loading and serialization of RDF data, and we have managed to re-establish the support of all standard formats for RDF. And right now we are working on the Sparkle engine, which is the core of Sparkle Corese, so it's a big work and a biggest work because, like I said, the inference engine, the reasoning engine, is based on Sparkle queries. We have a lot of optimization in the legacy code that we want to keep because they are very useful. And we have the LDScript language that adds a very interesting feature to Sparkle. And the Shackle engine that comes afterward also is based on Sparkle. So this is the core of our work right now. And once it's done, we're confident that we'll be able to work fast on the next step will be the Shackle and the reasoning engine. And once it's done, we'll reach the V5 of Corese for Corese Core. And once we've reached this, we'll be able to finally release the V5 for the 4 other applications of Corese. And while doing that, we've also, of course, the GUI have work that has started. So it's not a completely linear process. We're already starting working on the different applications. And we also have other applications, such as the graph rag, so that's the fact that the W3C is working on new standards for RDF. And we're also going to see if you can add new optimization to the queries and to the reasoning and to the Shackle application. We have also working on a new approach to federated queries, to connectors, to other solutions, and to the usage of Corese in a cluster of servers. And thank you for your attention.